Hello and welcome to Advanced Programming Techniques. Here I will show you how to represent infinite data structures. In fact, programmers already use infinities all the time, but they are rarely aware of it. In Python, you might be familiar with the built-in hash sets. You can take many individual values and then easily put them together in one hash set. Later, you may look up contents of those sets and check whether a particular value is a member. The greatest advantage is that mutating those sets by adding and removing elements is very efficient. Now, the situation is completely different for infinite sets. Python already provides a couple of built-in infinite structures. You may know them as, for example, the string type, or integer type, or boolean type, and so on. In order to check whether an individual value belongs to any of those sets, you may use the following built-in function. What's most important here is that we cannot add or remove elements. In fact, immutability is the most fundamental feature of all infinite structures. In order for something to be mutable, it must be finite. For a moment, let's go back to hash sets and see what kind of operations can be performed on them. We can use Python's set comprehension to build subsets. The standard library also provides us with intersection, union, and set difference. There is even Cartesian product, although it's a bit of an eyesore. It's possible to perform all of those operations on infinite sets as well. However, understanding the way it's done requires a major shift in our thinking. There are no library methods that we can call. We need to develop our own. But to do this, we need to ask ourselves, what is a set? Take a look at this. You might be thinking that this is a set, but actually you're wrong. This is a set. In particular, this function. This x is merely a parameter for this function. Especially you can see it if you write it like this. Here, this is the set, this is the member being tested, and this x, it's merely an extra parameter. Can you think of any way to write this function in such a way that it doesn't take the parameter? Well, yes, you could for example write this. This is the exact same set as this one, but here the data is encoded directly in its implementation instead of being a parameter. And in fact, you can encode any finite set in a similar way. What's most important about this approach is that it allows us to introduce our own infinite sets. For example, take a look at this. Here, the set y can be any of these three values, or it can be any integer greater than 5. So you can see that there are infinitely many values that belong to x. Now, we can finally introduce operations on infinite sets. What is a union? Union contains all elements that belong to one or the other set. And it's very easy to implement. Take a look at this. We created a new set, x union y, that contains all elements belonging to x or y. Similarly for intersection. Here there is a new set, x intersect y, that contains all elements in the intersection, that is those that belong to both x and y. Set difference is implemented as follows. Subset of x can be taken like this. Lastly, Cartesian product looks like this. Again, this is very similar to the intersection, except that this time we take two parameters and check each one of them independently. First whether x belongs to set x and then whether y belongs to set y. In more mathematical notation, it might look like this. Given some pair of elements, we can check whether it belongs to the product of x times y. At this point, you should see something really interesting. You can take this function, and in order to check whether this tuple belongs to this set, you just take it and apply it to the function as if it was just a single atomic element. You might even imagine that we could write something like this. Unfortunately, this is not correct Python syntax, but this notation can show you some interesting connection between tuples and function arguments. But this is a topic for another video, so see you in the next one and thanks for watching. Be sure to see my blog for more interesting content like this.